So let's say we have this sum, 1 over 1 plus the square root of 2 plus 1 over square root of 2 plus square root of 3 plus 1 over the square root of 3 plus square root of 4, and so on until the last term, plus 1 over the square root of 99 plus square root of 100. How would we simplify this expression? The first thing we can do is rationalize the denominator for each term in the sum by multiplying both the numerator and denominator of each term by the conjugate of the denominator. The conjugate of 1 plus the square root of 2 is 1 minus the square root of 2. So we multiply the first term by 1 minus the square root of 2 over 1 minus the square root of 2. The conjugate of square root of 2 plus square root of 3 is square root of 2 minus the square root of 3. So we multiply the second term by square root of 2 minus square root of 3 over square root of 2 minus square root of 3, and so on. We should do this for all the terms in the sum. So after we've done this, we should simplify each term by multiplying the numerator and denominator separately. The first term turns out to be 1 minus the square root of 2 in the numerator, and the denominator is 1 minus 2 if we use the difference of squares formula, since 1 plus the square root of 2 times 1 minus the square root of 2 is equal to 1 squared minus square root of 2 all squared, which turns out to be 1 minus 2. For the second term, the numerator is square root of 2 minus the square root of 3, and the denominator becomes 2 minus 3. We can simplify the rest of the terms in the same way. You may notice that for each term, the denominator has a value of -1. This is because in the original expression we started with, the integers inside the square roots have a difference of 1 in each denominator. That is to say, 2 and 3 have a difference of 1, and so does 3 and 4, and so on. This ensures that when we rationalize the denominator for each term, it becomes integers with a difference of 1 rather than square roots. So this expression is equal to 1 minus the square root of 2 over -1 plus square root of 2 minus square root of 3 over -1, and so on until the last term. And notice how the denominator in each term is -1, so we can combine this into a single fraction. So this equals 1 minus square root of 2 plus square root of 2 minus square root of 3 plus square root of 3 minus the square root of 4, and so on, until plus the square root of 99 minus the square root of 100, and this is all over -1. Notice how a lot of terms cancel out here. So this negative square root of 2 cancels out with positive square root of 2, minus square root of 3 cancels out with square root of 3, and the negative square root of 4 will cancel out with the plus square root of 4 that comes after that. And this goes on until the second last term, where the negative square root of 99 would cancel out with the plus square root of 99. So we're really just left with two terms, which is 1 minus the square root of 100 in the numerator, and of course this is divided by -1. Well, the square root of 100 is just equal to 10, so this is just 1 minus 10 over -1, and if we simplify this fraction, this just equals 9. So the result turns out to be a nice integer value. So here's another similar sum. 1 over 1 plus square root of 3 plus 1 over square root of 3 plus square root of 5 plus 1 over square root of 5 plus square root of 7, and so on until plus 1 over square root of 119 plus square root of 121. So the first thing we should do is rationalize the denominator. So then this becomes 1 over 1 plus square root of 3 times 1 minus square root of 3 over 1 minus the square root of 3 plus 1 over square root of 3 plus square root of 5 times square root of 3 minus square root of 5 over square root of 3 minus square root of 5, and so on. And now we can use the difference of squares formula to simplify this expression in the same way, so this becomes 1 minus the square root of 3 over 1 minus 3 plus square root of 3 minus the square root of 5 over 3 minus 5, and so on. By this point, we can see that the denominator of each term has a value of -2, and this also comes from the fact that in the original expression, the integer pairs in the square roots of each denominator have a difference of 2. So for example, 3 and 5 have a difference of 2, and 5 and 7 also have a difference of 2. So this expression becomes 1 minus the square root of 3 over -2 plus square root of 3 minus square root of 5 over -2, and so on until the last term. And since each term has the same denominator of -2, we can combine the fractions and rewrite this as 1 minus the square root of 3 plus the square root of 3 minus the square root of 5 plus the square root of 5 minus the square root of 7, and so on until plus square root of 119 minus the square root of 121, and all of this is divided by -2. So we can see that a lot of the terms cancel out, since negative square root of 3 cancels out with plus square root of 3, minus square root of 5 cancels out with plus square root of 5, negative square root of 7 cancels out with the plus square root of 7 that comes after that, and this continues until the second last term, where negative square root of 119 would cancel out with the plus square root of 119. So we're just left with two terms in the numerator, 1 minus the square root of 121, and this is all divided by -2. The square root of 121 is equal to 11, so this is just 1 minus 11 over -2, and if we simplify this fraction, this is just equal to 5, which is another nice integer value.